Hello, and welcome to our sixth of six information sessions on the topic of industrial hemp for Indigenous businesses. In this information session, we will be talking about the processing of industrial hemp fiber to derive the various end products desired. These information sessions are brought to you by the Indigenous Chamber of Commerce of Ontario in partnership with the Tequah-Tagamu Nation of New Post Reserve. My name is Keith Wilson, and I would like to talk today about industrial hemp fiber processing. In session 1, we learned about the history of hemp and its huge impact on our civilization. In session 2, we learned about the agriculture of growing hemp. In session 3, we learned about the seed harvest and all the products derived. In session 4, we learned about the processes required to transform these seeds into the desired products. In session 5, we learned about the other main component of the harvest, the fiber, and all the products derived from the fiber. Today, we will be talking about the processes required to transform these fibers into valuable end products. In this information session, we will be talking about the processes involved with making products from hemp fiber. I'll concentrate on hemp paper, hemp textiles, fiberglass, hempcrete, and pellets. And I'll do that to narrow down the most feasible value-added product for the TTN Cochrane area. Each product will require a different process to develop the desired end product, but the processes all begin with the plant in the field. The fiber process from planting to the end product has a few differences than that with seeds, but both processes involve choosing a seed, planting and growing the plants, harvesting the plants, and preparing the harvest for transport. The first step is the selection and purchasing of the right fiber seeds to suit your location and soil conditions. Crop trials and field testing conducted in northern Alberta in 2018 found that the Anka strain had the highest fiber yield of tested strains. Anka is the second most commonly grown strain in Ontario. Anka plants will complete their growth cycle in about 110 days, but you will want to harvest the crop before it blooms for better quality fiber. We will go over this point later. There are many different strains that have their own unique genetics, such as being more frost resistant, more drought resistant, and more pest resistant. The Anka seed is available in Ontario and can be purchased from a number of certified industrial hemp seed distributors. What about planting? Well, industrial hemp fiber plants should be planted much closer together than hemp seed plants. This is important so that the plants compete for sunlight and grow upwards and not outwards. This ensures more of the valuable long fibers and increases the quality of the fibers. The plants can reach 4 meters in height. This close spacing allows a canopy of industrial hemp to form. That prevents unwanted weeds from getting any sunlight. This hemp canopy cuts down the weeding you'll have to do and cuts back the herbicide use as well. Like any plants, industrial hemp will thrive when fertilized according to their needs, usually about the same amount as any other field crop. However, they do require sufficient rainfall and are not drought resistant, but are drought tolerant. Hemp requires about 20 to 30 inches of rain during the growing period, and irrigation may be necessary if precipitation is less than adequate. It uses twice as much water in light soil than it does in medium soil. Once the plants are mature, they are ready to be harvested. Harvesting plants for fiber is also different than harvesting for a grain yield. As with any field crop, a standard combine harvester or a side-mounted sickle mower is used. Care must be taken when harvesting hemp, as the fiber is exceedingly strong and will tend to wind up in the mechanism. Cutters must be kept sharp, otherwise the plants will tend to wrap around the combine parts, which will need to be constantly cleaned out. As we learned in previous sessions, the fiber plants are harvested earlier than hemp plants grown for seeds. The plants should be harvested before the flowering stage because after the hemp plants start to flower, there is a buildup of lignin, making the fiber more difficult to cut and process. As we learned in the last session, large amounts of this lignin inhibits the breakdown and separation of the fibers. After cutting, the plants should be left lying in the field for a period of time. This is called retting of the plant, which is the first stage in fiber processing. If the crop must be taken off the field due to winter approaching, the retting can be done under cover in an enclosed space. The length of time required is dependent on temperature and humidity. A warm and wet environment will speed up the process. Cold and dry will lengthen the time required. If retting is not available, then the fiber separation process becomes longer and becomes more labor and energy intensive. Once the crop is ready, it is pulled off the field and baled. Leaves, roots, and excess plant growth are left in the field to be plowed back into the soil. Whether or not the fiber is retted, it will have to be baled. The baled fiber is taken to a dry storage where it will await shipping. The storage methods will be different depending on the farm and the equipment available to that farm. The fiber bales can be shipped to a processing facility, or they can undergo preliminary processing first, called decortication. This is the next stage in processing the fiber plant stalks, the separation of the long and short fibers, essentially a little like shucking corn. Traditionally, this was a manual process involving repeated turning and bending of the stalks until the fibers separated. The operation is now performed by mechanical means in a machine called a decorticator. This decortication process can be performed in a facility close to the farm to minimize shipping large bales. The result of this decortication process happening on the farm is that the long and short fibers are now separated and can be shipped to different processors, depending upon the desired end product. In a previous session, we mentioned the high-quality paper that can be made from the long hemp fibers. However, the fiber length of any raw material must be adjusted depending upon the paper being manufactured and the machinery being used at each paper mill. For most other papers, other than hemp, a number of harsh chemicals are used in order to break the lignin bonds in the fibers and to bleach the darker wood fibers. And because you don't need as much of those chemicals to break the lignin bonds, and no chlorine bleaching is required for the much lighter hemp fibers, the amount of pollution to the environment is much less. The long fiber length also makes hemp paper much stronger and more difficult to tear. In an earlier session, I mentioned the most common pulp and paper process, the chemical Kraft process. Let's talk about the connection between this Kraft process and hemp paper. The Kraft process started in the 1800s as a process to release the lignin bonds in pulp using temperature and pressure. This is an expensive and complicated process producing a lot of toxic waste. However, it allowed the production of huge amounts of paper products from existing plant growth, like the boreal forest. Of course, this resulted in the clear cutting of billions of trees and environmental damage. This production of huge amounts of paper products from wood spelled the end of hemp paper, linen paper, and other specialty papers. However, paper that uses the Kraft process ages poorly and yellows in time. Hemp paper is chlorine-free, which is a huge environmental benefit, and it has a much longer lifespan and is much stronger than wood paper. In our information session on industrial hemp fiber, we talked about the usage of the long fibers in making valuable products such as rope, twine, blended textiles, and cloth. The processing for all these products start with the long fibers being spun into threads at a processing facility. These threads are then wound further into yarn, which is sold directly, or it can be passed on to the next processing facility to be woven into fabric and heavy textiles. Depending on the blend of different fibers and the quality of the hemp fiber, the fabric can have different weights, thread counts, colors, and varying flexibility, toughness, and softness. The thread can also be wound into twine and rope. The textiles are shipped to various manufacturers to make clothing or any other fabric-derived product. Another use for the long fibers, as well as the short fibers, is in the making of fiberglass matting. Traditionally, fiberglass is produced by forming a mat of spun glass fibers and then using a chemical binder to hold them together. The resulting fiberglass mat is then coated with a chemical resin and molded into the required shape, such as a car fender. Replacing the glass fiber with hemp fibers has several advantages. The first advantage is that the spun glass fibers are very dangerous to work with, whether it's working in the factory or during installation, especially when particles are inhaled after cutting and grinding. Another advantage is that hemp fiber is an organic substance and is much less harmful to the environment, unlike traditional fiberglass, which is toxic. The short hemp fibers can be used as blown insulation in the attics of houses without any further processing, instead of using the normal insulation that's made from fossil fuels. The fibers could also be used to make insulation bats or panel boards, which are again normally made from fossil fuels. This is important to note for the environmental benefits of switching to industrial hemp as a fossil fuel replacement. If you want to learn more about some of the other environmental benefits of industrial hemp, check out the information session on the agriculture of hemp, which is session number 2 in this series of 6. The hemp fiber particles can be mixed with cement and poured into molds to produce something called Hempcrete. Hempcrete is an environmentally friendly and energy-efficient material for building homes and other structures. Typically, a concrete mixture is made up of 60 to 80% of specific types of sand or gravel called aggregate, suitable for this purpose. The hemp fiber replaces that sand and gravel, which can help with the global shortages of these types of specific aggregates. There are a few approaches to the Hempcrete process. The fiber can be shipped to the building site and be mixed on-site as the Hempcrete is being poured. The fiber could be mixed with the cement at the processing plant and arrive on-site, already integrated into the mixture. The Hempcrete could be poured into wall forms, for example, to achieve the result of a high thermal efficiency rating with light weight. The fiber can be mixed with the cement and poured into forms to make blocks. These blocks are then shipped to the site for constructing a building. As was mentioned in a previous session, these lighter blocks result in lower shipping and labor costs. Also mentioned in an earlier workshop, the waste from producing hemp products, whether grain or fiber-based, can be pelletized into saleable fuel pellets. If the fibers are not being separated or processed further, both the long and short fibers can be pelletized instead. This turns the plant waste into a saleable product. The fiber will have to be chopped and perhaps ground to achieve the desired particle size to make different types of pellets. After the pellets are ready to go, they are fed into a pellet mill using a conveyor. The pellet mill can be of an extrusion type, where the machine forces the particles through small holes to form compacted tubes of particles, which are then cut to size. The pellets are then weighed and bagged for sale. For higher production rates, a hammer mill can be used, which uses more energy but is much faster. In both cases, moisture will be required to achieve cohesion between the particles. Thank you so much for joining me today for our talk about industrial hemp fiber processing for our 6th of 6 information sessions. Hopefully, you've learned a little more about the processes that are required to bring to market the various hemp fiber products. These information sessions are brought to you by the team at ICCO in partnership with the Tequah Tagamu Nation. My name is Keith Wilson. Thanks again for joining, and if you haven't already, I encourage you to watch all 6 videos to get a more complete understanding of industrial hemp for indigenous businesses.